Hello everyone. I hope you are doing great. This is Chandrakumar signing in from Purnia, Bihar. Today we are going to look into the topic of rainbow formation, a very important topic to understand light. So let's dive into the concept rainbow formation. Rainbow formation. For rainbow to be formed, there are some conditions required. So foremost we'll be studying the conditions required for the formation of rainbow, and then we'll dive into the ray diagram of how rainbow is actually formed. And that is where we'll come to know the formation of rainbow and why the rainbow is formed. So let's go into it. Okay. Now, the conditions required for the formation of rainbow. There are basically four conditions which has to be fulfilled for the formation of rainbow. First is a source of light. Source of light can be any light, but preferably we'll be talking about sunlight. It has to be any bright light. Intensity has to be good. So first and foremost thing is sunlight. There has to be a bright light. Second point is water droplets. For the formation of rainbow, there has to be water droplets. Why? Because water droplets act as prisms, and it is at this place where light splits up into its constituent colors. So, for the formation of rainbow, uh, water droplets are absolute must because this is where the light breaks up into its constituent colors. Now, next, the third point, angle of light. That is also very important. The angle of sunlight, it must be around 42 so, degrees, all right, relative to the observer's eye. Relative to the observer's eye. Remember it. It has to be relative to the. Now, the fourth condition required for the formation of rainbow, the observer must be positioned with their back to the sun and facing the direction of the rain or mist. This is very important. The source of light has to be behind the observer. So these are the four conditions required for the formation of rainbow. Now let's look into the formation of rainbow. So first, we'll bring in the sphere. Okay, we'll consider the raindrops to be spherical for our convenience, so that ray diagram becomes easy for us to draw. Okay, we'll assume the raindrops to be spherical. Okay, so this is the raindrop. This is the raindrop, right? This is the raindrop. All right. This is the sphere where light will hit. All right. Uh, let's. This is the incoming sunlight. It will hit the surface of the sphere. And for the purpose of ray diagram, we'll always draw the normal. It's very important. It becomes very convenient for us to draw the rays, the reflected, refracted, and mm, these rays are very easy to draw if you draw the normal. All right, and we follow the laws of reflection and refraction as we go along. So at this surface, basically, what is happening is when sunlight hits the sphere, over here, basically both reflection is also taking place and refraction is also taking place. But at this surface, we'll be considering only refracted part of the ray. All right. So this is the place where refraction takes place. All right. Reflection also takes place. Remember it. Reflection also takes place, but we'll be considering refraction at this surface. This is the light splits up into its constituent colors. Okay. Basically red and blue. And we know that red has the largest wavelength, whereas blue has the shortest wavelength. All right, and so the blue light deviates the most, and red light deviates the least. So if you have any confusion regarding this, we can make a video on this also, on the why as to red light bends the least and blue light bends the most. All right, so this is basically the phenomena. It's a good topic to be looked upon. We can cover it in some other lecture. All right, let's focus on the ray diagram. So what is happening here is light is splitting up into its constituent colors, that is Vibgyor, all right, and the red light is deviates the least and refracted the least, and blue light is refracted the most. Next, I hope you're understanding. If you have any questions, you can comment and ask me. All right. So this is the normal. We'll draw. We'll always take the help of normal. All right. So at this surface, at the second surface, also reflection is also taking place, refraction is also taking place. But we are interested in the reflected part of the ray. All right. Over here, there is a misconception that total internal reflection is taking place, but it is not so. Keep in mind, over here, total internal reflection is not taking place. All right. So we'll see how rays are reflected. This is the reflection part. Over here, we'll be considering the reflected part of the ray. The red light gets reflected and the blue light gets reflected. And at the third surface, over here also reflection will also be taking place and refraction will also be taking place. But we'll be considering only refracted part of the ray. All right. So we'll draw the normal. Again, we'll draw the normal, and then we'll do the normal drill which we do in the ray diagram. So this is the emerging red light, and this is the emerging blue light. All right. So remember this now. Now we'll be looking at how light is coming and how light is exiting. So keep in mind this figure, how light is entering and how light is exiting in the sphere. And now next. So this is how the white light was. This is how the white light was entering the sphere and white light was splitting up and then exiting. All right. So next we have the observer somewhere here on the ground. All right. And he will receive some of the light. Let's consider he's receiving the red light. All right. Although you could assume blue light over here, the process would be the same. Next is the red light reaches the observer, and then there is also there'll be also drops that are below, which will be also uh, performing the similar action to this droplet. And then from here, the blue light will be entering the observer's eye. So now you're getting to the point where you know why red light is on top and blue light is below. This is also a very good question that comes in. Why red light appears on top and why blue light appears below? So this is the reason why this is happening. All right. So over here, the rest of the colors, all only for blue, all the rest of the colors will also be formed in similar fashion. All right. So along this line, along this line, along this line, there will be similar droplets which will also be reflecting, which will also be emitting red light along this path, which will also be emitting red light along this path. All right, and over here, all the raindrops which appear on this line will be uh, emitting blue light. So we look into this. See, similar. All the drops on this line will be emitting red light, and this will cause a higher intensity of the rainbow, so that the rainbow can be clearly visible. This is the reason. Similar in the case of blue light. All right. When this happens, we see a clear rainbow in the sky. When this happens, we see a clear pattern of the rainbow in the sky. So this is basically the reason why you see rainbow in the sky. All right. Thank you for watching the video. I hope I have cleared the concept of the formation of rainbow. Thank you.